8b, 0.2. Okay, now, you know that integration means summation, correct? Okay, when we want to find the mean of anything, how do we do it? We use this formula called symbol, pi, xi, am I right? So for continuous variable, the probability, we have the probability density function, correct? Yes. So if we want to find the mean, we have to integrate from the limit of x given, the possible value of the variable given, and we have to the probability times by the x. So sum. So this will be x fx dx. So that is the formula. Am I right? Okay, now. And for standard deviation, the formula go like that, correct? Yes. So when we come to continuous random variable, it will go like that. And all these things can be done using your graphic calculator. All involve integration. Understand? So you will be integrate from A to B, all the possible value of x are A to B, then x squared fx dx, take away the mean square. So that is how the formula come about. All the summation sign you change to integrate. Okay. Then how to count the median? So that means median is like that. Probability of x less than the median must be equal to what? 0.5. Or you can say probability of x more than the median must be equal to 0.5, correct? Yes. So when come to integration, when come to continuous variable, we will do it like that. Let m be the median. Okay, which means that I integrate from the lowest value of x until the median, the probability density function, I must get 0.5. Am I right? Or I can say if I integrate from the median to the highest value of x for the probability density function, I must also get 0.5. So you can work it in any other way. So that is how all these formula come about. So all these formula you have to bear in mind. Are you clear? So if you want to find the mode, you sketch the graph, the highest point, that is the mode, the one with the highest probability. Do you get me? So that's all. So all these three formulas are very important. You must write down in your notes. And everything when you count, how you do it, using your graphic calculator. We will never do it manually as what the book shows. You do it manually, you waste a lot of your time. Are you okay? Can or not? Okay, now I want to straight away discuss one of the questions in your textbook, that is question 10. Bear that in mind, when I give you the probability density function, correct? it doesn't mean that it must be only a single function. You look at question 10. Okay, I will discuss that question. Okay, question 10, exercise 5B.2, question 10. Okay, I want you to take out your graphic calculator and sketch the graph for this function. Okay, I want to see how you sketch. Can you please try part A first? Okay, I just want to let you know for your SAT fine, correct? Definitely there will be one question like that. What function I want to give you is up to me. So now you try to sketch the graph. Okay, I'm doing that as well. You key in the first one into Y1. Okay, so what you can do is, if in the exam, correct, what you can do is you can do like that. I write my Y1 as 125 over 18x squared. My Y2 as 9 over 10x squared. Zero otherwise. They always will tell you zero otherwise one. Huh? Question 10. 8. Sorry. Do you know why I wrote 5? I just have the exercise 5 from the other class. You see? That is a problem with teaching two different intake. Never mind. Okay, Yuja. Thank you. One x cubed, x squared, correct. 125 x. Okay, sketch the graph. Faster sketch the graph, try. Even without me showing you, see whether you know. Okay, the first function only valid from 0 to 0.6. Then the second function is you start from 0, x equal to 0.6 to 0.9. You stop that. So that is the domain. You get me? You can go to window, you set your x equal x minimum as 0, you set your x maximum as 0.9 or 1, up to you. Okay. But you have to stop at 0.9. Okay, I will put 1 instead of 0.9. So up to you. Okay, let me settle the thing. Then you do a zoom fit. Okay, I'm going to teach you how to. Nothing come out. Okay, you will get a very funny graph. You can't see the thing. You go back to the window. Then you set your y maximum to become very small, maybe 0.5. Then you go back to the graph. I know. If you set your window, look, you have to learn how to manipulate. If you set your window, where's the other graph go to? Oh, 0.5 too small. I put 5. See how it goes. If you set your window, okay, I set my window x minimum as 0, and then x maximum I set as 1, correct? When I do a zoom fit, correct? I got a graph that is, I can't really see anything. So I go back to window again. That is how you're supposed to play with it. I go back to window again, then I adjust my y maximum. To 1, you also can't see. To 5 or 10. No, you just play around with it. You just play around with it, please. So until you can see 2 curves like that. Am I right? Okay, may I know what is the coordinate of the intersection point for this one? You get the intersection point first. The intersection point may not be the cutting point, may not be, I'm telling you. In this case, you see whether it's yes or not. In this case, yes. The intersection point is the cutting point. So this is my y2, this is my y1. So listen, and it happened that the intersection point is the cutting point. Correct? Happen, sometimes it's not. So if it's not, then what should we do? You go and figure it out. Certain problem. Okay, now, listen. So when I sketch the graph, yes, you play with the window, you get this. So you just need to keep going back to the window, change the y. Understand? The y minimum must be 0. That's it. Because we are talking about probability density function. Are you okay? Hello? Can or not? Can I? Okay. So done? Ready? Okay. So now how are we going to sketch the graph for this? This is what the graphic calculator showed you. Okay. So what I need to do is when I sketch, I will until here I stop. 0.6. Then after that, I will do this way around. So I know that this is my y1, and this is my y2. And I stop at 0.9. The rest is 0. So that is how the graph goes. Are you okay? This is what you are supposed to show me. And it's good that you can show me what is the coordinate of this point also. What is the coordinate of that point? 2.5. Is it? Okay. Okay, I ask you, is this a valid probability density function? How are you going to prove that this is a valid probability density function? Hello? Suggest to me, how am I going to prove that? How to prove? This is a valid probability density function? I must say sum of the probability equal to 0, equal to 1, correct? So in this case, how am I going to write an integral expression? Can I just write as 1 or I have to write as 2 parts? Yes, I have to write it as 2 parts. 0 to 0.6 y1 dx. So you see, during the exam, how good is it if you write down the first function as y1? So you can just write in your any working, you write y1. So you don't have to keep repeatedly writing this. Okay, dx plus integrate from 0.6 to 0.9 y2 dx. So what is the answer? Do you get one? So actually, I'm doing this for part B already. Calculator. So you have to be very versatile with your calculator. Do you get one? You get one. So I'm done with part B. So part B, you cannot say, oh, check whether it's a valid probability density function. You say, oh, sum of the probability equal to 1. Cannot. You have to write down the integral expression. Understand? Okay, now I'm going to, from here, look, I'm going to teach you sometimes the question can vary. How they vary? Look, they purposely don't give you this. They put this as K. They ask you to find the value of K. So how am I going to do that? So what you can do is, please, you can use your solver. Can you please take out your graphic calculator, solver, go to solver. Okay, so what are you supposed to key into solver? That means I don't know this. See or not? So now, so this one will be in my E1. This one will be in my E2. Please get into your solver. And this one I put as X in my solver. You see whether solver can help you to get 0.9. Try. So I'm trying to use one stone to kill two birds. So in the exam, I can even give you this unknown here. The M here also can. So it's up to me. So at the end of the day, it's still bound down to this concept. Sum of the probability must be equal to 1 in order to be a valid probability density function. So do you know how, can you get? Yes. Can I? So you see, so for this particular part, graphic calculator is very important. If you everything you want to do it manually, you kill yourself for it. Hello? Do you get me? Okay, good. So make a note that they can give you an unknown of the variable, then ask you to find that variable unknown. It's usually the beginning or the end, or in between, when they interchange the function. Okay, now find the mean and median and the mode of X. Okay, now find the mean, you should be able to do, correct? So how to find the mean? Let's go to part C. So find the mean, what you need to do is, you just need to write down in your graphic calculator, hello, mean equal to, depend on the limit, you use the different function. So if 0 to 0.6, I will write x, y1 dx. You must multiply by x to get the mean, plus sum from 0.6 to 0.9 x. The probability density function is y2. Okay, calculator, get the answer. You write down this one. This is very important. Whatever you write down is very important. Understand or not? Then the rest key into the calculator and get the answer. Don't challenge the question. Don't try to do it manually. You are penalized by the time you don't blame Miss Doe for it. Okay? Okay, got it? What is the answer? 0.5899. Okay, is that the answer? Okay, good. Now, for median, we have to do some checking first. Every time when we do median, we must know where is the location of the median. Okay, so I want to teach you how to check where is the median. So since we got two functions, correct? So what I'm doing is I have to check what is the probability for this area first. I have to check first, 0 to 0.6 y1 dx. I check first. You want to check the other way around also can. It's up to you. Okay, check. Can you tell me what is the answer? 0.5. Five what? I want to know the exact value. You cannot say 0.5. I'm checking only. I haven't find the median yet. It cannot be 0.5. Yes, what is the answer? Yes. Glady, what is the answer from 0 to 0.6? Exactly 0.5. Oh, so then you can make a conclusion already. So therefore, median is 0.6. Are you clear? So now, let me explain to you why I say I must check. Okay, so I'm going to give you the three different scenarios. If, okay, for example, if I give you a probability density function, okay, one is going like that. This one goes straight up, then this is another function. This is my y1. This goes straight up. And here is my, okay, 0 to a. Then this is my y2. Okay, look. So I didn't give you the function. So now for median, hello? If I integrate from 0 to a, y1 dx, I got less than 0.5. Okay, I check. So where is the median now? You tell me. So therefore, median is between A and B. Am I right? Am I right? Because this area is less than 0.5. So median must be somewhere here. Am I right? Hello? Can or not? You get me? So therefore, I integrate median to be y2 dx. I get 0.5. So I use my solver to help me to solve. Can or not? You get what I mean? Faham? Or no? So that is how you have to check first. Then you know where is the location of the median. Then you write the definite integral involve the median as one of the limit. Then you go to solver, then you get the answer. So do I need to show you another scenario? I think you can analyze by now, right? And for this one, I check, I happen to get here, I make the conclusion here. Hello? So every time when you want to find the median, what must you do first? Check for the first region first. Very easy one, you can use your graphic calculator to check. So the other way around, then you do the other way around. Okay, so that is median. Okay, yes. Y2, sorry, Y2. So if I want to use Y1, how would I write? Okay, I can also use my Y1, but it will be more troublesome. No? You have to involve Y2 as well. No? So we just try our best just to involve one. Can or not? So depend on it lie in where. No? Do you get what I mean? Okay, good. So done with the median. Okay, mode, you should know the highest tip. No? So in this case, the mode is also 0.6. So if you look at this distribution, do you think it's skew left or skew right or symmetrical? Skew a bit left, a bit negatively skewed. Why? Because the median is smaller than the mean is a bit smaller than the median. Correct? So skew a bit left, negatively skewed. Okay? Can or not? Okay, now, can I move? Is it okay? I move on to the next part. Okay, then I move on to part D. Okay, when you have a look at the part D, find the variance and the standard deviation of X. So what you can do is, we find the standard, you find the variance first, then after that you square root. So the variance, what is the formula? You integrate from 0 to 0.6 x squared y1 dx plus integrate from 0.6 to 0.9 x squared y2 dx. Take away the mean square. What is the mean? Just how we get it from part C, correct? So you just write down the value squared, then key in your calculator and get the answer. Then the standard deviation, you just square root it and you get the answer. That's it. So writing out properly is very important. Then the rest is just relax and press into your calculator and get the answer. That's it. Got it? Yes, Africa, you look like you are. What is your problem? Sure, you got the answer already. Huh? Yeah, because variance, you must have the x squared. So that is a formula you have to follow. And because they got two functions, so you have to break into two parts and do. You just have to follow this formula here. You see or not? This is a formula. This is for mean. Yeah. because this is a probability density function. So you have to follow the formula. That's all I can tell you. And the rest is using your graphic calculator and get the answer. Okay, everyone? Got the answer? So when you involve two functions, you have to be very careful of the value of x involved. That's why I purposely discussed this question first. Yeah, so you can check the answer from your scientific calculator. Okay, let's talk about part E. Okay, look, the variable that involved in this question is from the variable that involved in this question is from 0 to 0.9, right? And 0.6. This is you have to use y1 function. This one you have to use y2. I purposely draw this is to let you visualize. So now if you have a look at, I want the probability of x between 0.3 to 0.7. So that means I have to be very careful because 0.3 is here. It go to 0.6. After that, it go to 0.7. You see, it used two different functions. Am I right? So when you want to find the probability, you have to write two different integral. You integrate from 0.3 to where? 0.6. This one, you use which probability density function? Y1. Plus from 0.6 to 0.7, that involve another probability density function. So use your calculator and get the answer. Are you clear? So the limit is very important. Which value of x you must use probability density function? You yourself have to observe it. So clear? Okay. So everything, try not to do it manually unless the question asks for exact value. Everything let the calculator handle because you want to do integration as well as finding the one is very troublesome. If in the exam, they will give you, if they really want you to integrate, they will give you the amount of mark for integration. All right. So, but for doing this exercise, everyone, please do it using your graphic calculator. Clear? Okay, good. So on that note, I finished this part. And I promise you, definitely there will be one question, some sort like question 10 in your exam. Are you clear? Okay, so can you please do the other part